Hello, Mr. Hein. And now what we're doing today is we're going to be using the chick problem, which we just talked about yesterday, to find an approach for this type of problem and understand what's happening here from a math viewpoint. And I'm going to show you an approach that you don't have to use, but you might want to use because it does come in handy sometimes. And that's the thing with math, is math sometimes gives us the tools to make more efficient methods, but they're not always needed. All right. So this was the problem from yesterday, the chick problem. How much did the chick weigh the day it was hatched on day 0? And we knew it grew 5.2 grams a day. And on the 9th day, it weighed 98.4 grams. Now, there are 3 approaches, most common approaches that I've seen. Approach number 1 is that you could make a graph of this data where, you would say, okay, I'm going to call this weight. And we'll call this down here days. And you said, okay, what do we know? Is that on the 9th day, 1, 2, 3, 4, 5, 6, 7, 8, 9. On the 9th day, it was 98.4 grams. All right. That's one of the things you knew. And then you knew it grew 5.2 grams a day. So if you wanted to find out how much the chick weighed the day it was hatched on day 0, you would go back 5.2 grams every day. So you'd minus 5.2, how many days? Well, you'd minus 5.2 nine times from that 98.4. And you could do that and you'd get the answer, but the problem with the graph is, see how we have decimals? A graph is difficult if it's decimals. So though you could have gotten it this way, and I think some of you did, it's not necessarily the easiest. The second approach you could have done is with a table. And a table is nice. I actually like this method quite a lot. So I'm going to make my table vertically this time, up and down. So let's call it day, which is our x, and weight, which is our y. Make a long table here, and we'll say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we know is that on the 9th day, it was 98.4 grams. And, sorry, my face is in the way. And if you wanted to find the weight on day 0, right, this is what you want. Well, you would just subtract 5.2 all the way back to day 0. And you would just use a calculator probably, because with decimals, it can be kind of tricky to do this without a calculator. And kind of like I just said, how many times do you minus 5.2? We end up minusing 5.2 9 times. Okay. Now, in both these methods, the correct answer was 98.4 minus 5.29 times, is you would have gotten 51.6 grams. And that was the correct answer for this problem, was day 0, it was 51.6 grams. And I can give you more problems, and you can do these 2 approaches, but a graph, not that easy. A table, this wasn't that bad because it was 9. But what if it gave you day 100? Are you going to go back 100 times? Maybe not. That's a really long table, so there have to be better methods. And this is the third approach I'm going to show you, approach number 3, and then we'll look at an example afterwards where we actually use the equation to get this answer. Okay. So how does that work here using the equation? So let's write down what we know. We knew that on the 9th day it was 98.4, and we knew that it was growing 5.2 grams per every day. Now, what we can see it says is that the 998.4 is actually a point xy. That's a time, a location. And this right here is a rate. That's a rate of change. So when we write our equations, what we know is that the equation is y equals mx plus b, where, remember, what's the m? The m was the rate of change. and the b was the start. But we don't know the start here. So in fact, in this problem, we want to find the b. Now what we can do is we can take the rate of change and plug that into m. That's the 5.2 over 1. And then remember that 9th day, 98.4, that's a point in x comma y. It's a fact we know about, a time in this problem. So then for y, we can put 98.4, and for x, we can put 9. And then what we're going to do is we're going to solve for b. Okay. So I'm going to do this with you. So then what this equation becomes is 98.4 equals 5.2 times 9 plus b. And notice I'll put the over 1, and that's fine. Well, now we're solving for b, so you're going to do 5.2 times 9, and then divide by 1, but dividing by 1 doesn't mean anything. So you get 98.4 equals, and I'll put my calculator right here so you can see my calculations. What's 5.2 times 9? 46.8 plus b, and just notice how I rewrite the equation every time. Go slow. Go slow to go fast, all right? And then how do you get b by itself? Well, this is a positive number. The opposite of positive number is to minus it to both sides. And what do you get if you do 98.4 minus 46.8? This will go to 0, and you're going to get b is equal to 51.6, which notice that was the correct answer that we got from the table. And what you might see is this wasn't new. What did we do when we saw this equation? 5.2 times 9. Remember, what did we do? We minus 5.2, let me move my paper, 9 times. Just like we did from what would have graphed, minus 5.2 9 times. That's what we're doing in the equation, and we minused it over. That's the 46.8 we minused over. So there it is from an equation, and equations work every time, and they typically have the same, it takes the same speed to do the equation every time. The length of the table doesn't matter, because the table, if it was 100, that becomes a longer problem. In the equation, it's the same amount of time for every problem. All right, let's look at one example to help you see this. So example 1. So what's the equation if we know that the slope or rate of change is, say, 3 over 2, and we also know, and there's a point we know, say 3, 7. What's the equation? Let's do, I'm going to change that to 9. Right. Now we're going to do it with the equation because we're going to take the equation approach, because that's what the new point of this is. You don't have to do it, but I encourage you to learn this. So write the equation y equals mx plus b, and plug in everything you know. The m is going to be 3 over 2, and this is a point x comma y, so then x will be 3, and the y will be 9. We write that problem with everything in it. Y equals 3 over 2 times 3 plus b. Now when multiplying, you multiply straight across, so then that's 3 times 3, which is 9. So then we get 9 over 2 plus b. 9 divided by 2, you can use a calculator, and that's 4.5 plus b. And then how do you get a positive 4.5 to the other side? How do you make that go to 0? Well, opposite of positive is negative, so you minus it. If you do it to one side of the equal sign, you have to do it to the other. 9 minus 4.5 is 4.5. That goes to 0, and we're just left with 4.5 equals b. And with that, we can write the equation of y equals 3 over 2x plus 4.5. And there it is. So given a slope and a point, we can get the equation and the starting value. All right. Hope that helps. Come to Offsides if you need it. Do your best on it. Bye-bye.